Hi there, welcome to the math therapist class. So one of my follower asked me to prove why any number raised to power of 0 is 1. So I have three ways to solve this or to prove this. So I have method 1, method 2, and method 3. So let me prove it on the board. By the way, my page name is Math Therapy. So do well to follow us on all social media platforms, even on YouTube too. So let me start with um, one of the rules of indices, that's exponential indices. We're using indices, so that's exponential rule. It says that a raised to power m divided by a raised to power n. Now, how do we solve this? Now, let's say that this is the same thing as what a raised to power what m hmm, minus n. Are we together? Just calm down. Now, if I say let m equal to what n, this simply means any place I see m, I substitute it with what n. So now this is going to implies that a raised to power what this place of m, now replace it with what n minus what n, and this can be simplified as a raised to power what n with together over a raised to power n, or you can still write it this way as a raised to power what n times a raised to power negative n, which can be written as a raised to power n times what 1 over a raised to power n, where this will cancel this and it give you what the answer is what is 1. Or you can still say where this divided by this, any number divided by itself, anything divided by itself is what is still 1. Have you seen that? That's the first method. Another method is called the negative rule. Negative rule. The negative rule states that if you have something like a raised to power n, is the same thing as what 1 over a raised to power n. So, for example, we say that let's pick n pick n to be equal to what 0, right? So let's substitute this. This is going to be a raised to power negative 0 equals to 1 over a raised to power what 0. By the way, negative 0 is the same thing as what 0. So we can still say here that a raised to power 0 over 1 over 0, where a raised to power 0 equals to 1 over 1, and this is still 1. Of course, you know that a raised to power 0 is still 1, and their output will still give us what is 1. And another striking one I'm going to give us is a kind of the one we call the function behavior, or I call it the limit. So let's use limit pattern, function behavior. We call it limit. So this one is kind of technical, but just pay attention. If we say that f of x equals to what a raised to power x, and we say that a here is equal to 2, so we say so a is equal to 2. So for example, if you say that 2 raised to power 3 is what 8, and 2 raised to power 2 is what 4, and 2 raised to power 1 is what 2. So what is 2 raised to power 0 now? Now, note that as the value of x decreases to 0, the value of 2 raised to power x gets closer to what? Gets closer to 1. Please take note. Note that as the value of x decreases to 0, the value of 2 raised to power x here does what? Gets closer to 1. So, if we say that 2 raised to power what? Negative 1. Let me start with 2 raised to power negative 1 is what? 0.5. And 2 raised to power negative 2 is what? 0.25. And 2 raised to power what? Negative 3 is what? 0.125. Such that x approaches what? 0, or x tends to 0, we can now say that 2 raised to power x equals to 1. That simply means 2 raised to power 0 is what? 1. And this is proven. So please kindly share this. Any among these that you understand well, please you can drop it on the comment section. Let us see. Thank you very much and have a nice day. Bye-bye.